Hi there, good to see you again. What we're going to do in this video is, given a velocity graph over the interval 0 to 10, we're going to try to determine the distance traveled on 0 to 10. And we're going to look at two different things. We're going to look at not only what our position is relative to the starting point, but we're also going to look at the total distance traveled and how those two things differ from looking at this graph. So remember that we know that the area between the axis and the curve is distance, because area, as you know, is length times width. But length in this case is the number of seconds, that's a t interval, and the v of t interval, the height, is measured in feet per second. So when you multiply feet per second times seconds, you get feet, which means it's a distance traveled. So since we have three different regions, we're going to look at three different intervals here. So first, looking at the interval 0 to 1, I notice that region is above the x-axis, or above the t-axis in this case. So that means that the area represents the distance traveled in the positive direction. So that means this area being 1/2 times 1 times 5 is 2.5 and measured in feet. Okay, now looking at this next region, it is below the t-axis, which means the value of the definite integral will be negative, but we still calculate it just as area because we know that the definite integral is related to area. It's the negative of the area if the region is below the axis, and it's equal to the area when the region is above the axis. So this is a trapezoidal figure, and we know that the area of a trapezoid is 1/2 times the height times the sum of the parallel bases. Now our parallel bases are 2 units and 6 units. And our height, being the side perpendicular to that, is 5. So that in total is 20, and that does represent a distance of 20 feet. It's just that it's moving in a certain direction. So if positive meant we were moving east, a negative would mean that we're moving west. But it is still distance. We can still interpret it that way. Now for our final region, we have a triangular region from 7 to 10. And that means that since it's above the axis, the actual distance traveled is equal to the area, but that also means that the definite integral is positive as well. So that area is 1/2, the base is 3 units, the height is 4 units, and that gives us 6, and we know that that is feet. Okay, so the two questions we have, the total distance. Well, the total distance, no matter which way you go, is just the sum of the areas, positive, and we just make them all positive. So that means this is 2.5 plus 20 plus 6, which is 28.5 feet. So, to understand this, think about, if you wear a fitness tracker. No matter what direction you're walking in, it still records steps. It doesn't take away steps if you start walking the other way. It's going to keep continuing to count in a forward, an accumulating number of steps. Now, as far as how far are we from our starting point, that's where the positives and negatives have an effect. So from 0 to 1, we've walked 2.5 feet away from the beginning point, but then on the interval 1 to 7, we went 20 feet in the other direction, and then from the interval 7 to 10, we have gone 6 feet back in the positive direction. So I'm going to call that a change in displacement. And that looks like 2.5 and 6 is 8.5 minus 20 is negative 11.5 feet, which means 11.5 feet in the negative direction. So again, if we said positive direction was east, this would mean that we ended up 11.5 feet west of the original starting point. And there is how we can use velocity to interpret distance traveled and change in displacement.